So here we've got to explain why this reaction is taking place and how we get the reactivity series of these metals. So what we would do is we'd take each sample of each metal that we've been given and we'd add it to solution of the metals in a spotting towel. We'd be watching and recording observations, so we're looking for any colour changes to the metal or to the solution that we are reacting it with. And the rule we have is that a more reactive metal will react with the solution of a less reactive metal, and the more reactions that a metal completes, the more reactive that metal is, so that would be higher up the reactivity series. So each bullet point is worth 1 mark in that answer. Next one, so we can get metals by extracting them from the earth. Explain why aluminium cannot be extracted by heating with carbon. So the problem here is that aluminium is more reactive than carbon, so it's higher up in the reactivity series. Carbon cannot therefore reduce the aluminium ore. What we'd have to do is use electrolysis to reduce the aluminium ore. So the first mark is for this bit, and the second mark is for one of these two answers being present. So titanium can be separated from dissolved impurities. How do we do that? So separate solids from mixtures, we're going to do distillation in order to do that. Okay, this next one is a calculation, and it wants us to calculate the number of moles in this 45,000 grams. So what I'm going to do first of all, let's write our Mr. Moles is underneath the mass triangle. And in this first bit, we are trying to find out, as the question said, the moles of titanium chloride. Okay, so the moles is going to equal the mass divided by the MR. The mass is 45,000. The MR in this case, we've got to do some little bit of working out here. So we're trying to do it for titanium chloride. I'll just do it. We'll do it over here. So titanium chloride is TiCl2. So I've got one titanium, which is 48. I've got 2 lots of chlorine. Now chlorine is 35.5 times by 2 is 71. Add those together. So we have got 48 plus 71, and that equals 119. Now, in this question, I'm actually going to get one of the marks for working that bit out. So MR is 119. We do that on our calculator, so 45,000 divided by 119, and that's given me 378.2 moles, and that would get me the second mark in that particular question. Okay, next bit says show that the 500 Okay, in this bit of the question, we are doing a calculation, and we want to find the number of moles in 45,000 grams of titanium chloride. So this is the formula for titanium chloride. And what I'm going to do here, because we've been asked to find the moles, I'm just going to write down that Mr. Moles lives underneath the mass, which is our triangle to do this kind of calculation. So moles of this titanium chloride, according to that triangle, moles is going to equal the mass divided by the MR. The mass is 45,000, and we're dividing it by the MR. So over here, let's just work that out. So it's TiCl4. So in here, I've got one titanium. So one titanium is 48. And I've got 4 lots of chlorine, which is 4 times 35.5, which is 142. Let's add those together, which is 190. So over here, I'm dividing that by 190. So 45,000 divided by 190, and that's given me 236.8 moles. Okay, marks wise, 1 mark for working out the MR for titanium chloride, and 1 mark for getting the number of moles correct there. It then says, show that 500 moles of magnesium is in excess. So what I'm going to do here is we can see that the ratio between these two is titanium chloride. There is 1 mole in the balanced equation, and that's reacting with 2 moles of the magnesium. So if I've just worked out that I've got 236.8 moles of this, what I'm trying to do is work out how many moles of the magnesium are needed. So to do that, what I'm doing here is doubling the moles of titanium. So if I times the 236.8, then I'm getting an answer here of 473.6 moles, and that is less than the 500 moles we've added. So in that case, because we've added 500, we only need 473. This is in excess. So if I was going to finish this off, I would say the reaction requires 473.6 moles of magnesium. 500 moles is therefore excess. Okay, right, the last little bit. So after the reaction, there's a mixture of solids of magnesium, titanium, magnesium chloride. Titanium does not react with hydrochloric acid. Suggests a simple way of separating titanium from the mixture. So what we would do is you would add hydrochloric acid to the mixture. The magnesium is going to react to form magnesium chloride. The titanium does not react. And then what you would do is filter the mixture to remove the titanium. Okay,